have, okay, I think I'll write radius r, 2r, 3r. 3 concentric shells, 3 thin concentric conducting shells. Read this one. Meanwhile, I'll add that thin conducting. Okay, no, 3 thin conducting concentric shells A, B, and C are given charges Q, minus 2Q, 3Q. Find potential of individual shells VA, VB, VC, and work them exagent in moving a charge Q naught from shell C to shell A. Now, what shall we do? What about the charge? Induced charges? We'll see once. Huh? This will help us a lot. What about the charge here? Plus Q. If you are supposed to show everywhere on the surface, that will take time. So I'm just indicating only plus. It is understood. This charge will be distributed uniformly on the surface of shell A. Then it should be minus Q. Am I right? Then what was the charge of the shell B? The shell B was given minus 2Q, no? Minus Q, the net charge should be conserved. So how much it should be equal to? Minus Q. Then this will induce charge plus Q, 2Q. Okay, this will be the charges on all surfaces. Able to understand? So I'll start with this one. Charge here plus Q. It will induce charge minus Q. Then on outer surface plus Q, minus 2Q plus Q. How much will be minus Q? It will induce charge. How much it is?
It will induce charge minus Q, na sir. Minus 2Q plus minus Q is minus 3Q, na sir.
Listen, plus Q, minus Q there, no? Minus Q plus Q will be induced, no? Minus Q plus Q will be induced.
Okay, sir. Yes, sir.
Okay, fine. Look at this. Minus Q plus Q. Plus Q minus 2Q, how much will be minus Q? Then again, resultant how much here is minus Q. So it will induce plus Q, minus Q. So 3Q.
Understood, sir.
Okay, ma. Yeah. So what is the net charge of a shell will remain constant due to electrostatic induction. They're getting the idea? What was the charge of shell B, shell C? 3Q. Okay, now also you see 2Q, 3Q. What is the charge of shell B? Minus 2Q. Minus Q, minus Q. What is the charge of shell A? Plus Q. A very important sign means I may ask you such things rather than asking some numerical. These are very fundamentals. Even on advanced, I'll ask you what is there in this one. Because a student must know first the basic things, no? Okay, you can, looking at this diagram, you can find out the field, or you're looking at this diagram, you can find out the field potential, anything let it be. Okay, let's calculate first potential of shell A. And this is for your reference. They may ask you. I'll push it to corner. Okay, now looking at this diagram. Okay, potential of shell A. No, when it comes potential, what we should do? Superposition principle. First, only shell A is there. What is the potential on the surface? KQ by R. Plus. Okay, then potential. Now potential at point A here. Where is the point? Point is here. Assume that only shell A is there. What is the potential? KQ by R. Then assume that only shell B is there, but point is here. You are here. I think I'll give some symbol. I'm here. Then first only shell A is there. Potential how much? KQ by R. Then assume that shell A and C are not there. Only shell B is there. Then where you are? You are inside the shell B. So what should be the potential that on the surface? So K minus 2Q by 2R. Then you are here. Assume that shell A and B are not there. Only shell C is present. But since you are inside the shell C, you are inside the shell C. So what is the potential on the surface? That should be everywhere inside. So K 3Q by 3R. So it will become KQ by R. There's a potential of shell A. Similarly, we'll take the potential of shell B. Now where we are now, okay, I'll remove this person. The person is here. For your convenient purpose, I'm showing that person. You are here. First, only shell A is present. Shell B and C are not there. Shell B and C are not there. Then in that case, so where you are at a distance 2r from this. So potential will be
Sir,
KQ by 2r.
sir, in A, you said that we should not electric. Okay, it's electric field. We are calculating potential. Yes, sir.
Potential superposition.
Yes, sir. Yes, sir. Thank you.
Yeah. No, I'm standing at point like on the surface of shell B. Then potential at what distance I am at a distance 2r. So what is the potential due to shell A? KQ by 2r. Then what is the potential of the shell B? I assume that shell A and C are not there. Only shell B is there. I am on the surface of that shell. So what should be the potential that on the surface? Then shell A and B are not there. I'm inside the shell C. So the potential should be K. These two will get cancelled, no? You could have chosen some minus Q, you would have got some different answers. Any charges you can pick up, doesn't matter. Even this radius R, 4R, 5R also you can pick up. Okay, I'll stand now here. First, only shell A is present. At what distance? I'm at distance 3R. So therefore, this will be KQ by 3R. At what distance I'm from shell A? At a distance 3R. So potential should be KQ by 3R. Then only shell B is present. Then shall we write 3R minus 2R? No. If you stand here, where do this whole charge will appear? So why you are writing 3R? So again, the similar to you're standing here, you are outside the shell A. Then for you, what will happen? If you draw a Gaussian surface, this whole charge will appear at center, like a similar to point charge. It should not be, it should be 3R only. You should not take the difference of this, wrong. This whole charge plus Q will appear at center for this person. It's an assumption like this from Gauss law. Similarly, the whole charge minus 2Q will appear at center O for this person. So this will be K. And the person is on the surface, so potential. Similarly, if you want to calculate electric field here, suppose if you want to calculate the electric field, the field at this point is only due to charge Q. Charge on shell A. If you want to calculate electric field here, the field here is only due to these two charges. The field here due to all three. Okay, we got the potentials, you see.
This is minus 2KQ by 3.
Oh, this is minus 2Q. I didn't see. Then I think it will be okay, 2KQ by 3R.
Yes, sir.
No, is asking now, is something is again troubling us. Work done by exchange agent in moving a charge Q0 from shell C to shell A. Some test charge it is. So it will not produce. So if I'll write. I think the test charge will not produce its own field. So let's not bother change in potential due to movement of this charge. No, any formula. Work done by exchange agent in moving a charge from where? From shell C to shell A should be equal to Q0 into VA minus VC. Can you remember this formula? So we know VA and VC, substitute there. Q0. VA is how much? KQ by R Okay, this much of work the X region should do to transfer a charge, test charge from shell C to shell A. Now some work done also will be asked. Okay, first for that you should know only the potentials of individual shell. So what we have calculated, potential of shell B it is. Okay, now we started with 2 shells. Now it is about 3 shells, like this, even 4 shells, let them give. Okay, we can manage. Thick shell, later tomorrow we'll focus on thick shell. You'll get confused, thick shell. Sorry, if I do for this also, will I get same answer? Yes, you'll get same answer. What is the net charge of shell B? Minus 2q, see, 3q. No need, no need. But if I ask you surface charge density, no, you have to be, you should think in this way. I'll scroll down. Next one, earthing of shells. So what is the primary concept of earthing of shells? What is the idea of that one? What is the potential of the earth? Potential of the earth, we consider it to be 0. So what is the concept in this involved is potential of earth. Electric potential and not gravitational potential. Electric.
So when should we use that other charge distribution diagram, sir? In the previous.
Not other charge distribution. If somebody has, find the surface charge density on all surfaces.
Okay.
You should know all things, my dear. Not like only like a question asked to calculate answer. Actually, this word electrostatic induction occurs. Looking at this diagram.